All right. Hello, everyone. Welcome to RISA Live. My name is Gary Yen. I work in the tech support team at RISA. Before we start today's presentation, if you are new to the channel, please hit the subscribe button and click on the bell so you won't miss anything new on the channel. Today's presentation has two parts. In the first part, I will briefly go through the reinforced concrete design features that we have in RISA-3D V18 version. And in the second part, I will give you kind of a preview of the new ACI 3.18.19 code changes in the next major release of our program. Now let's get started. Today, I'm going to use this model for demonstration. So if you joined our research training before, you might be familiar with this model. This is essentially a concrete frame that's taken out from a parking structure. As you can see that in this model, it has several different types of concrete elements, including concrete beams, concrete columns, and some concrete walls at the end. And before we jump to the model, I wanted to kind of show you a little bit about some of the global settings that's related to the concrete. As in the code, you can see that for the concrete code, we have different version of ACI code, Canadian code, and some British code, Euro code, and so forth. So here I'm going to go ahead and select ACI 3.18.14. And you can see that we have another two tabs. One is called concrete, the other one is the rebar. So these two tabs are specifically for the concrete design in RISA 3D. In the concrete tab, you can see that we have a lot of options for determining the analysis method. For instance, for doing your column design, when you consider the biaxial bending, you can either use the exact integration method or the PCA method. And we have some other options like what do you want to consider for your compression stress block? You can either use the ACI typical rectangular stress block, or you can use the parabolic stress block. And we have some other checkbox here for detailing and detail report. Here, I want to talk a little bit about these analysis using cracking section checkbox. If you check this box, the program will essentially use the cracked moment for inertia for your concrete members, the ICR. So for modifying these ICR factors, you can go to the members spreadsheet. And in the member spreadsheet, you can see different tabs. Here, we will look at the concrete beams and columns. So for these tabs, you can see that we have an ICR factor listed in there. So you can modify this ICR factor between 0 to 1. And here I want to talk about a little tip that we have in RISA 3D is, for instance, if you're in the spreadsheet and you don't know what is the parameters you're looking at, you can go ahead and click this cell. And on the left-hand side, the property panel, on the lower left, you can see that we have some additional explanation of what this parameter is. In this particular case, you can see that if you leave this blank, it'll default to 0.35 for the beams and 0.7 for the columns. These two values are essentially the ACI recommended value for the ICR. Now let's go back to the global model setting and look at this rebar tab. So in the rebar tab, it basically gives the user some option to define the rebar that they want to use, for instance, here for a column. You can define your minimum and a maximum steel reinforcement ratio you want to use for your column design. And here, there's a box for shear reinforcement for your beam. So here, you can choose a number of regions you wanted for the program to optimize your shear reinforcement. You can choose either 2 or 4. So what the region does is essentially the program will optimize your shear rebar spacing based on the actual applied load in this particular region. So in the mid-span where you have a less shear load, you can have a larger spacing compared to the end. You can have a tighter spacing due to the larger shear force at the end of the beam. Now let's go back to the model. I wanted to show you some general design parameters or properties for reinforced concrete members. Now in the V18 version of RISA 3D, if you click on a member, on the left-hand side, it'll show a property panel, which listed all the parameters and information of this particular member. As you can see that we have some general information, for instance, the member label, length, what type of material, and the section you are using. And here I want to talk a little bit about the reinforcement ratio that you can define for reinforced concrete members. So here, there's an option that you can ask the program to optimize the rebar based on your design rules. That's the design rule option. So to modify the design rules, you can go to the member design rule spreadsheet over here. And there is a tab called concrete rebar. So if you hit the concrete rebar tab, you can see that we have a lot of information related to what size of flexure rebar you wanted, the minimum and maximum, and the shear rebar size, and how many legs you wanted for your stirrup, and some cover information. Another way to edit these parameters is to click this triple dot button for a particular design rule. Once you clicked it, you can either create a new design rule or edit or view an existing design rule. So here I'm gonna view the existing one. As you can see that we have this nice little figure that show you all the cover information, and you can define all those design parameters in here. And depending on what type of member you're using, you can do the beam or column design rules definition separately by switching from here. Another way of defining the reinforcement is to use the custom. So if you use a custom rebar, when you hit this when you select this custom rebar layout in the dropdown, there will be an additional box popping out, and then you can select either an existing custom rebar that you created before, or you can go ahead and hit this triple dot button and create a new custom rebar. As you can see here that you have the option of adding, top rebar, bottom rebar, and then you can hit enter to create a multiple layer of reinforcement. So these essentially the rebar layout editor give you a lot of freedom to edit your reinforcement in the member based on your project need. So this type of custom rebar will be mainly used in an analysis type of project. Now going here, there are some additional design properties for this concrete beam. As you can see that we have some factors. The B factor, B effective, which is used for define the T beam or the L beam. So some of the users, they might want to use part of the slab as the concrete beam section. So here we give you the option of defining that. So you can go ahead and define the B effective on the left-hand side of the beam and the right-hand side. And also you can define the slab thickness. By doing this, the program will have an understanding of how big of the section you wanted for your T or L. Here, just as a trial, I'm gonna go ahead and put 24 inches for the B effective left and right. And I will just use an 8-inch slab over here. So one of the good thing about this is in the render view, after you modify this and zoom in, you can see that the T-beam shape is actually showing the changes. So you can easily review your T and L beam in the render view. For column parameters, it's pretty much the same for the general properties, and the design properties, as you can see that we have some properties that are specific for the reinforcement for concrete columns, like your embrace length for the column, and the effective length K factors, and some parameters that were used for considering secondary effect. Now going to the concrete wall panel, the way to define the reinforcement in the wall panel is a little different than the typical concrete members. In the wall panel, the only option to do it is to use the design rules. So here we select design rules as typical. So if you wanted to review these design rules, you can click this triple dot button, go ahead and edit and view these design rules. And here you can see that you can go ahead and change how many layers of rebar you wanted, the rebar size and cover information and all those. And some of you might want to use kind of a custom rebar layout for your concrete wall. So there's actually a workaround that is to define your rebar size and then make your maximum and minimum spacing to be the same. This way will force the program to use the specific rebar spacing that you want. So after introducing all that, I'm going to go ahead and run this model. So before the presentation, I have already created a lot of load combinations over here, including some gravity load, wind load, and then seismic load. So in the RISA-3D V18 version, we're actually now using a multi-thread solver, which means that each core of your CPU will be solving one load combination, and they will all be solving simultaneously. So for a large model, it'll save you a lot of solution time. So here, I'm going to go ahead and use the solve batch plus envelope. So this is a relatively smaller model, so it runs pretty fast. I'm going to go ahead and close this so we can view some results. So one of the big improvement that we had for RISA-3D V18 is the detail report. So now we provide the full calculation details if you want to check the design checks for a certain member. So here you can hit the detail report button and hit a certain member. And then you can see that the detail report layout is a lot different than the previous version. On the top, we have some general information of this member, followed by some force diagrams for this beam. And you can click this diagram and review the values in detail. And then we have all these tabs, which essentially show you all the designs that we performed for this beam. As you can see that we have some apply load, and we have some bending checks, top and bottom. And we have some shear checks here, and some development length check, detailing check, and some rebar detailing. And here, all these tabs are expandable. So if you go ahead and click one of the tab, you can see that it shows you all the detailed calculations step by step. Here we show you all the parameters that we used to get the final design result. And here we also put the description of this parameter and also the code references if there's any. So this is very handy for you if you wanted to go ahead and create a calculation, like a report or a calculation package. So you can go ahead and print this. You can go ahead and hit this print button and then generate a PDF for the calculation report as part of the calculation package for review. And for the shear design, as we can see here, we have some typical shear checks. And as I mentioned in the global model setting, we choose the 4 regions. So each region were checked separately, and then the information were provided over here. And we also have some development length check over here. And at the very end, we have some figures that shows what flexural rebar and shear rebar we use for this beam. The column detail report is pretty much the same layout. As we can see here, we have some axial bending check, flexure check, and also some shear check. And at the very bottom, the rebar detailing, we provided you also the PM diagram and a moment interaction diagram, and some figures that show you what reinforcement we use for this column. Now I'm going to show you a little bit about the wall panel detail report. So the wall panel detail report, the layout is a little bit different. On the top, we have the wall panel elevation with the rebar, the program selected. These are some general properties of the wall panel. And here is basically a summary of the design check result. And on the bottom, we provided you a detailed calculation for the different wall regions. Here, this is just rectangular wall, so we only have 1 regions. So if you click that, you can see that we have all this shear moment axial diagram and the region information. And for each of these tabs is for different checks. And you can go ahead and click this. It'll provide you some additional information on the checks for this wall region. And we also have here the PM diagram for this wall region and some cross-section detailing. I think with that, I very briefly went through the reinforced concrete design features in RISA-3D. I'd like to move to the second part of my presentation. As many of you know that ACI released the new 3.18.19 code last year. And in this new code, lots of major changes were made to the code provisions. As RISA, we're going to introduce this new ACI code in the next major release. So I wanted to give you kind of a preview of all these major changes in the new code that we will have in our program. The first one I want to talk about is now the ACI allowed you to use a high strength reinforcement, namely the grade 100 rebar. As you may imagine that if you're using a grade 100 rebar, the yield strength of the rebar is a lot higher than the typical grade 60 rebar. So the yield strength is 0.0035. Now, because of that large strength difference, a lot of the requirements in terms of ductility and steel strength has to be modified accordingly to reflect that changes. For instance, now ACI require you the member to be tension controlled for beams, and then the string to qualify as a tension control for grade 100 is a 0.0065, which is a lot larger than the previous code requirements, which is a 0.005. As you can see that the ductility requirement has become more stringent for a higher grade rebar. The second change that I want to mention is the shear contribution for the concrete VC term. So this is probably the biggest change for the ACI in this version. For most slabs and members with the shear reinforcement smaller than the minimum required shear reinforcement, you cannot use the 2 lambda square root of M prime C equation anymore. So now the new equation for VC is actually a function of flexure rebar reinforcement ratio rho W. And another factor that was introduced in ACI was a size effect. So the size effect is essentially talking about a phenomenon that the concrete strength will reduce as the size increases. So with this factor, for a large beam, for instance, if your depth is bigger than 36 inches, you may have a more than 40% reduce of the shear capacity term VC. This is quite significant if you consider those deep beams, a big portion of their shear capacity comes from the concrete term VC. And the next one I want to talk about is now ACI require you to consider the biaxial shear interaction when your DCR or your UC is bigger than 0.5 in both directions. So previously in the code, you can consider the shear design in X direction and Z direction separately. You don't need to consider any interaction. But in the new code, they require you to consider the interaction when in both directions, the UC is larger than 0.5. And the next one I want to talk about is the special shear concrete shear wall. The ACI now add a factor to amplify the shear demand for special concrete shear wall. This requirements is essentially for taller building. So if you have a tall concrete shear wall building, which are, let's say, higher than 20 stories, your shear demand for the So I think we might have some technical difficulty here. I just mute my microphone and see if you guys can hear anything now. So I was just saying, to sum up my presentation today, we briefly went through the reinforced concrete design features in RISA-3D, and we also talk about some of the major changes that we have in the new ACI 3.18.19 code. As always, if you have any question regarding our program, please feel free to contact our tech support by email or by phone call. Thank you for your attention today, and see you guys in the next RISA Live.